Section 6, Unit 2, Tools, Tool Holding, and Work Holding for the Vertical Milling Machine. Introduction. This unit will focus on properly selecting cutting tools, properly mounting cutting tools, properly selecting work holding devices, and securing work. Tools may be mounted either with arbors or directly by their shanks. A on top, some arbor type cutters and mating arbors for use in a vertical milling machine, and B, some shank type cutters and holders for use in a vertical milling machine. Devices must have a taper to be directly mounted into the spindle. Cutting tool materials. Cutter materials be solid high-speed steel, solid carbide, steel cutter body with replaceable inserted carbide cutting edges. The solid carbide and inserted carbide cutting tools for milling. The ANSI carbide milling insert identification system. It shows you all the different types. Of course, on the left it's going to be your stronger high force, and your right it's going to be weak low force. Various insert shapes are available, with shapes of an insert has an effect on its strength and forces credited during machining. Cutting tool materials. The rake angle is built into the cutter body. A positive rake is shown. Notice that the inserts must have an adequate clearance angle to prevent rubbing. Several different methods for mounting inserts to milling cutter bodies. The inscribed circle is shown on two different insert shapes. The cutting edge angle of an insert is shown. A positive rake angle is shown. The standardized ISO identifications for various workpiece materials are shown. So P is steel, stainless steel is M, cast iron K, aluminum alloys is N, heat resistant alloys is S, and hardened steel is H. Proper cutting tool storage prevents contact with each other. Tool chest drawer lined with dividers and plastic or carbide containers for protection. End mills resemble twist drills bits but have cutting edges on both ends of the sides. Some types available is roughing, ball nose, radius, corner rounding, chamfer, and tapered. End mills with 2, 3, 4, and 6 flutes are shown. Center cutting end mills with 2, 3, and 4 flutes, and a non-center cutting 4 flute end mill. So you can see that the helix is actually coming through the center, so that knows you're center cutting. Whereas if you got a circle in the middle of it, you cannot plunge cut with them. There's a few roughing end mills. As you can tell, the rough edges, it helps it to grip to where it don't chatter near as much, and you can take deeper cuts. On A is a 2 flute and a 4 flute ball nose end mill, and B is a carbide inserted ball nose end mill. Radius or bull nose end mills. So that's a radius, and then this would be a bull nose. A set of shank type corner rounding end mills, and an arbor corner rounding cutter, a high speed steel chamfer end mill, and a carbide insert chamfer end mill. And then you have a tapered end mill. Flat surface milling cutters. Create a flat surface on top of a workpiece. 3 common types is fly cutter, shell end mill, and face mill. A fly cutter uses a single cutting edge. The cutting edge of this fly cutter was ground for my high-speed steel blank tool bit blank. And a high-speed steel cutting end mill, a carbide inserted shell end mill, and an arbor used for mounting them. Face mill with a integrated R8 shank. Specialty milling cutters. Specialty cutters is T-slot, dovetail, woodruff key set, splitting saw, and form mill cutters. And that shows a solid high-speed steel T-slot cutter. There's a dovetail cutters. There's a woodruff key set cutter. There's some high-speed steel slitting saw and a carbide insert slitting saw. There's an arbor type concave mill cutter. And there's a convex mill cutter. Tool holding. R8 spindle taper is a standard in most conventional milling machines. Devices include end mill tool holders, drill chucks, Morse taper adapters, shell mill and stub arbors, and R8 collets. An R8 taper top and a Morse taper bottom. An end mill tool holder with an R8 shank. Notice it's got a set screw. And a Weldon shank end mills. Note the flat machine on the shanks. So that's where that set screw will go. Drill chucks with an R8 shank. An R8 shank Morse taper adapter. An R8 shell mill arbor. An R8 stub arbor. An R8 collet. Alright, work holding. Devices include hold down clamps, milling devices, chucks and collet fixtures, vacuum plates, magnetic devices, adhesive based devices, and custom fixtures. Pins placed at the table T-slots can be used to align a workpiece or work holding device. A on the left, a step clamp assembly usually contains a T-nut, stub, clamp, riser block, and clamping nut. And B on the right, a bolt and a washer may be used to place the stud arbor. To place the stud and nut. So instead of using the stud and the nut, you just use a bolt. A typical set of step clamp and with T-nuts, clamping nuts, and assorted sizes of studs, clamps, and riser blocks. After sliding the T-nut in the T-slot, it should be positioned as close to the work as possible. A shows the proper step clamp setup. The T-nut on the stud. The T-nut and stud are close to the work. The back of the clamp is slightly raised by the riser block to direct the clamping pressure toward the work. The stud length provides adequate thread engagement in both the T-nut and clamping nut. And B, avoid situations where the back of the clamp is lower than the front of the stud is closer to the riser than the work, directing more clamping pressure toward the riser and the work. Toe clamps are first secured to the table with T-nuts, then the adjusting screws are tightened to grip the work by its sides. So you got pressure going down at an angle instead of on the top. Toggle clamps can quickly be locked and released without using the tools, the use of tools. A typical milling machine vise. The milling vise works well for holding parts with parallel sides, round work, and D-shaped work. The solid jaw of a milling vise is perpendicular to the bottom for machining perpendicular surfaces. The parts of the milling machine vise. You got the movable jaw, the bearing surface, the solid jaw, the bed, the clamping slot, and the removable handle. A milling vise mounted on a swivel base allows for angular positioning of workpieces. An angle vise can be moved on a hinge and then locked into position, work nearly at any desired angle. The sign vise can be set using gauge blocks for very precise angular positioning. A three-jaw chuck fixture for milling. A square and hex-shaped collet blocks. An indexer can use collets or three-jaw chuck. It also tilts for angular positioning. Work secured on a magnetic chuck for milling. This adhesive-based work holding process secures the adhesive with a ultraviolet light. Custom milling fixtures are sometimes created to hold unusually shaped parts.